All right, so how do you graph a line? Let's see here. I want to graph this line. I'm going to graph that color blue. Right? And so, what's the slope to this line? What's the y-intercept to this line? So the y-intercept, so y equals mx plus b, right? So y equals mx plus b. What is that? The definition of a line, right? Okay? And then I just plugged in some values, right? So I have y equals negative x minus 3, given, right? And now I get to plop out values. I get to unsubstitute, right? Unsub, meaning m is equal to negative 1. B is equal to negative 3. Why? Definition of y equals mx plus b. Right? The slope, definition of slope, definition of y-intercept. Right? That's this whole idea of y equals mx plus b. It gives us our slope and it gives us our y-intercept. And now I can graph it. I graph it at negative 3. Right?
Yeah.
Except I'm going to graph it in blue. And B, so M is negative 1. What's that mean? Down 1, right 1, right? Or up 1, left 1, right? Is there a stick? A stick up here.
Oh, yeah. Okay. Okay.
Okay. Thank you. All right.
Sounds going to. I don't know what happened.
All right. No, that's the easy part. Now we got to do, how do we graph a parabola? To graph a parabola, I have a 4-step plus 1 method, right? The plus 1 is your x-intercepts, if you need them, right? And so the x-intercepts is basically negative b plus or minus the square root of b squared minus 4ac all over 2a. Anyone remember that formula?
Yeah.
Remember that one?
Yeah.
That's your x-intercept. That's called the quadratic formula. That's your plus 1. We don't have to do that one if we don't want to. That's why I call it the plus 1. If they ask you to do x-intercept. This is your x-intercept. Just so you know it, okay? But the first step to graphing a quadratic, right? Well, I have to know the quadratic, so let's get the given. Y equals x squared plus 2x minus 3. Given, right? All right. Now, my first step to the 4-step method is to find the axis of symmetry, okay? So the definition of the axis of symmetry means I need to take the derivative of the function. Oh wait, I'm talking calculus to geometry students. I can't do that. Sure I can. Because the derivative is not that hard, okay? To do the derivative, now the way that the Algebra 1 is set up, they always say, hey, we just want you to do 2ax plus b. Okay? And that's equal to the axis of symmetry. Okay? And what is 2ax plus b? Well, if you have ax squared plus bx plus c, right? And that equals y, and I take the derivative of that, then to take the derivative means I have to take the exponent times the coefficient, 2 times a. Subtract 1 from it. What's 1 from 2? 1. Okay, and then I do that to this one. What's 1 times b? What's 1 from 1? 0. That means that's x to the 0, right? What's x to the 0? No. 1. Right? And this is where my students are like, but I don't understand. Because this is where I say, and c goes away. And they're like, why does c go away? And I said, because that's what my calculus teacher told me. And they're like, but I want to know why. And I'm like, well, give me a few days. I'll figure it out. So I go home and I study it. And I'm like, why the heck is c going away? I don't understand it. And I'm like, oh, stupid me. What's going on here? I have an x here. X to the 0. What's 0 times c? 0. What's negative 1? So 0 minus 1? Negative 1. But what's x to negative 1 times 0? Right? And that's why it goes away. So this goes away. This goes away because that's just 1. And what do you end up with? 2ax plus b. Right? And so that's the definition of finding the axis of symmetry. Right? So we use 2x plus 1, right? Sorry, 2. So 1 times 2 is 2, right? Equals, and then you'll be like, well, why are we making it equal to 0? Right? And it's very, 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 very cool. Because at some point, we know that this is smiling or frowning. How do I know that this one's smiling? Because it's positive. Yeah. Because it's positive, I know this one's smiling. So this function looks like this. Or I should keep it here so that the camera can see it. But this function looks like this. Smiling. Okay? Hopefully this is... there, now you can see it. So it's a smiling function. Right? And from that, then I know that this has a bottom to it, right? Now, the whole thing about finding the derivative is it's finding the instantaneous value. Instantaneous value means what's going on. So when we look at this instantaneous value, there's a slope there, right? And that's a negative slope, right? And this is a positive slope, right? This is how I come up with my slope face, by the way. This is my slope face. Negative, positive, no solution. 0, x equals, y equals, hello. So, but what happens between a negative slope and a positive slope? There's one point between negative and positive that it becomes what? Flat, which is 0 slope. The mouth. And at that point, whether it's this way or this way, that flat point is 0. And it's only 0 at one point. That's it. Out of all the points, the infinite points on this equation, there's only one point where it's 0. And that's when the slope is 0. Okay? And so, by setting this equal to 0, that's what I know that the slope is 0 at that point. When x is that amount. Does that make sense? Okay, so now I can solve for x. So I solve. And I got to call this something. Right? Well, this is given, and then this was the derivative. Right? But it's also what? The value in the slope is 0. Right? The value when slope equals 0. Or otherwise known as the axis of symmetry, right? The axis of symmetry is the point at which the x creates a zero slope, okay? It's the highest point or the lowest point on the parabola, okay? In this case, the minimum, right? All right, let's solve. Minus 2, 2x equals negative 2. What did we just do? Right? Divide by 2, x equals negative 1. What did we just do? You see why these properties become invaluable? They're telling me what's going on at every single point in my equation. It's invaluable. You see what I'm saying?
Yeah.
I know you think it's a lot of extra work, but the coolest part about doing it this way is there's no teacher that can tell you that you didn't show your work good enough. Never. If you do it right. Okay? All right, next. So I know at negative 1,